So, hello friends. Today we are going to see how we can create a binary tree by using C++. So, before moving to that, I would like to tell you like how the tree is being constructed. So, if I'm telling like we have something as binary tree, so we know that all the time the tree consists of what? If I'm calling one tree as a binary tree, so tree is what? Tree is the set of here few things. Like if I'm writing one tree as a binary tree, so we know that tree consists of what? Tree consists of nodes and tree consists of some edges. So these are the two basic things that are required into any tree. So like in the previous diagram also we have seen how the tree looks. So just let me go here and let me open that diagram. So it was just available here only. This was I think the diagram. So here into this diagram also you can see this is the structure of one binary tree we can consider which belongs to a complete binary tree category. Okay, so here you know that here what term we can consider as a node and what term we can consider as edges. So all the time the thing which is holding your data we are calling that as a node. Here one is the one node, 2 is also the one node, 9 is also the one node here. Parallelly you can see like we have the right subtree of that main tree is consisting 3 as the one data node, 5 is also the one data node. So all the time you can see these are a sum of nodes. Even 5 is also here the one node and 6 is also at the one node. So these are different nodes. And what are the edges? So edges are what? Edges are the lines which are connecting to those nodes. So this is the one edge which is connecting to the node 1 and 2. Then here one line is available for connecting for 1 and 3 node. So these are the edges which are connecting to those nodes, which are connecting to those datas, which are pointing to those datas. So these are how the nodes are connected with other nodes, we can say, or with their childs. So here also how we can create now a tree. So all the time you can see one node has its left and right child. Like if I'm telling 2 is the one node I have available, so 2 also has its left child and right child. So 2's left child is what? 2's left child you can see here is a 9 which is pointing to toward left side, and 2's right child is what? It's 5 which is pointing toward its right side. So we can use one of our linear data structure to connect those nodes together. So that data structure is available here, which is a doubly linked list. So I would like to tell you that how we can connect. So this is the structure of one doubly linked list. So we'll use this structure and we will see how we can create a tree, or how we can simply create as of now the node. So this is the one node structure of doubly linked list, where you can see now that structure is consisting what? It's consisting the central part as data, next part has a next node, and here the left part is consisting a previous part. So what is it? Here you can see the next part is showing it holds the address of next pointer, and the left part is holding the address of previous node pointer. So similarly we can consider here the same kind of structure for drawing our tree. Let's say rather than having the address of previous and next node, we can consider the same structure here, which will be divided into three parts now. So the central part now again will be holding data. So here I can say I will have a data present at the central part, but the next part here will hold now the address of right child address you can hold here inside this part. Like this we can just try. Right child address we can store here into this section, and it will hold the address of left child. Like left child address we can store into this part. So same structure we are going to use for creating our tree. So all the time your data will be holded into the middle part, that will be data. Okay, And now the previous pointer of your this doubly linked list will hold the address of left child, and the next pointer will hold now the address of right child. I hope you are understanding. This is the right, this is the left. So by using this, what we can do, we can now create a node. So this is our code blocks. Here you can simply either go for any structure or you can go for creating a class. So what I will do is I will simply create a class for a node. So you can declare any user defined class. So I am writing that class name is what, it's a node. Into that, what data members we require. So you can go into previous diagram, what we have drawn, we have considered something as data. This was the data that we have considered. So I will require one member here as a data. So I will write here int data. Okay, if you are allowing to store only numbers, you can go for int data. If you are storing the nodes in terms of alphabets, you can go for char. So like that we can consider. The next, for the same class type, we can create a two pointers. Let's say the pointer which is now holding your left child will be what, it maybe you can consider as left. Okay, just let me go here, you can say that will be left. Okay, and the pointer which will hold the address of right child you can say as right. Okay, so that will belongs to the same class type. So what I will do is I will write here left is the first pointer which is now holding the address of left child, and for the same class type I can have one more pointer that you can consider as right pointer. Okay, that's it. These are the basic data members we require. If you will implement the tree, we require to access those same data members up again into subsequent, we can say, functions that may require to call your datas, or that may require to point to the address of risk upcoming nodes. So what I will do is I will make them public so that it will be accessible. Okay, so you can just make it public. Apart from that, what we require, whenever I will create the object of this class node, automatically we can say something should be happen. So we know that a constructor is the one thing that allows automatical execution of data whenever the class object will be created. So whenever you will create an object, automatically constructor will be called. And my assumption is what, whenever you are passing any node into the new object, it should be stored inside this class node. Okay, I know that as of now it looks completely hypothetical, but you will understand whenever we'll go for actual tree implementation. So as of now my requirement is what, whenever I will do what, I will create an object or I will create a node which hold or which might hold some data. I don't know what could be that data. That data maybe, let's say, some 7. So 7 should be stored. But when it will be stored, whenever you will create an object, automatically it should be stored. So I will require here a constructor. Okay, so that constructor will do what? It will hold your that data. So that data will hold what? That data will hold whatever the parameter you will pass through that respective object. So I will say that parameter is what, X. It should be stored here. Okay, that is my requirement. So this is the thing that we have to do inside a constructor. So I hope you are with me and you are understanding something. So whenever we will go ahead with actual tree creation, you will definitely get this. The next thing is what? Next thing is, apart from this, initially your left and right pointers should be what? It should be null. Rather than writing or declaring both the times, you can say both has the same type. So you can declare write this also into same line. And initially what I am telling like left and right both should be what, it should be initially null. So you can declare like this also, or this is optional, though you will not write this, by default it will be null. Okay, so this is just what your single node creation. I can say this is just a single node that we have created as of now. Okay, so for creating a single node, how many lines of code we require? So we require this kind of code. This is the tree available here for us. And into this tree, if you want to add every single node, you will require this much of lines of code. So I hope you are understanding this. If I am just thinking, I want to create a single node, so I should go for this code. Okay, I hope you're understanding this. So in the next video, what we will do, we will see like how we can have stack, because stack we will require for we can say a non-recursive traversal. So we will see like how we can go first in recursive way, then we will think for a non-recursive also. Okay. So we'll say next time how we can create a stack. So as of now, I'm stopping here. Thank you for watching this.